Thank you. Like I said, I'm Dustin Graham. I'm a mobile developer. I've been doing mobile development for about 10 years. And tonight I'm going to talk about, I'm getting kind of an echo. Okay. So the title of my talk tonight is called Flutter for React Developers. Learn once, write in more places than you thought. You know, the React catchphrase is learn once, write everywhere, right? But before we dive into Flutter, React Native, and why you as React developers ought to care about it, let me talk about myself just a little bit. About me, so first and foremost, I'm a husband and a father of 4. My wife and I, we have 4 beautiful kids. I got 2 older boys, Peter and Joseph, 2 younger girls, Lizzie and Becca. And we love going to Disneyland. This last year, we had season passes, and we went a total of 12 times to the park. We are gluttons for punishment, and we hope to go back again someday soon. Professionally, like I said, I'm a mobile app developer primarily. Been doing mobile app dev for about 10 years, pretty much since modern mobile dev kind of took off. On the native side, I've built Android and iOS applications. So I've written a lot of Java, Kotlin, a lot of Swift and Objective-C. On the cross-platform front, I've done a lot of Xamarin, Unity 3D, React Native, and for the past year, I've been doing Flutter. Really excited about Flutter, and that's why I'm here to talk about it. I work at Ron Turley Associates, RTA, we call it. We specialize in software that helps companies manage their vehicle fleets. We've got this bread and butter core desktop application that we've been building and maintaining for the past 35 years. It's massive, it's complicated. And me and my team, we're bringing this into the modern age with web APIs, a web application, and a mobile app. There's my GitHub and Twitter handles if you guys want to connect with me. So let's dig into this. Okay, so what is Flutter? So Flutter is a portable UI toolkit that you can use to be able to build high performance, seamless, beautiful applications on any platform that can push pixels. Currently, specifically, Android and iOS. Allows you to build these applications from a single code base and be able to provide a native experience to your users. So the question that you probably ask, you know, at a ReactJS meetup is, why Flutter? Why are we talking about Flutter tonight when we're all here to learn about React? I'll tell you 3 things that I think are really important for you guys to understand about Flutter. First, there's certain advantages that Flutter has for building native applications that has over React Native. React Native is an awesome technology. It's definitely something that pushes the state of the art forward, but there are certain advantages that we want to talk about for Flutter. Second is that React developers, if you know React, you have the knowledge, skills, and mindset already in you to be able to be productive in Flutter from day one. Flutter is inspired by React. You'll be able to look at the code, understand what's going on, and a lot of the same tools and techniques that you already know and love will be instantly usable. And third, this is an emerging platform. There's a lot of excitement. It's on Android and iOS. It's going places, and new emerging platforms provide you guys with new opportunities, and it's a place for you to use the skills and techniques you already know to be able to apply it to these things. All right, so the elephant in the room is, well, Flutter and React Native kind of fit in the same space. What's the difference? So let's talk about React Native. Who in here has written some React Native code before, built some mobile applications? Good, that's awesome. You guys are already ahead of the game. So let's just make sure that you kind of set the foundation. So React Native is a mobile cross-platform framework. This means that it utilizes, it allows you to build a native application from a single code base, and React Native allows you to write your React application code and provides this bridge to be able to bridge your JavaScript into native code. So when your users get the end product, they see a native experience. They look at a button, at a text box, at a widget, and it looks native, it behaves native because it is native. It's using the same UI toolkit components that all the other applications use, but it's being driven from your JavaScript code. Flutter is a little bit different. Flutter is a portable UI framework. Flutter is able to deliver that same native experience that your users come to expect. When they see a button, it looks like a button, it feels and behaves like a button, but it's not a button. Not the same thing as that comes packaged in with the UI toolkits that are provided on the platforms. So when you write a button in React Native, it's actually a UI button on iOS, it's an Android button. But on Flutter, Flutter provides all of its own drawing. Flutter has all this custom drawing. The engine's written in C++ and uses Skia 2D graphics APIs to be able to draw these layouts. And the framework that you write in is written in Dart. And that Dart code is compiled down to native code. So down to the metal native ARM instructions. So it's working super fast. The difference is because Flutter provides its own UI toolkit, they can have certain optimizations, certain ideal code paths. They can make fewer compromises because they don't have to have this bridge, which when running on iOS goes this way, and when running on Android goes this other way. This is why when React Native first launched, it was an iOS only thing. And Android support kind of came afterwards because this coordination between the two platforms is complicated. So to break it down into a quick metaphor, on the right here, we've got my concept of React Native. You guys have already owned a car. If we wanted to make that car autonomous, well, it didn't come autonomous out of the factory, but we could stick in a really sophisticated, awesome robot that could just chauffeur you around, and we could get autonomous driving out of the car you already own. Flutter's a little bit different. We wanted an autonomous car, and we can build one from the ground up. It can still get around the city. It can still use all the same services that your car can, but it was designed from the ground up as a cohesive unit to be autonomous. And these are kind of the difference of mindsets between the two platforms. So I mentioned that your application code is written in Dart. You know, what is Dart? Who's written any Dart code before? One guy, two guys, nice. All right, well, I'm three, so we're in good company. Okay, so Dart, what is Dart? Well, Dart's a nice blend of, I think, a lot of good things. It's strongly typed, but it's got powerful dynamic features. It's object-oriented, but it has nice functional features as well. It's got single-threaded execution, but it's got this super easy isolates API that allows you to use multiple cores if you need to. You got futures, which are just like promises. You got async and await keywords. You've got a first-class streams API for working with reactive data. You've got a super great feature-rich standard library, and really all these things put together, you've got a nice, familiar, comfortable language that's gonna look right at home for anybody who's written any Java, C#, or JavaScript. There's a high-performance garbage collector, and because the Dart and the Flutter teams work close together, there's a tight integration with the Flutter framework, so it's able to handle all the garbage that a reactive framework likes to put out when you're creating lots of objects. And the other great thing about Dart is it's got this really unique dual compilation mode. So while you're in dev mode, it's just-in-time compiled. So you can have these super fast dev cycles, sub-second dev cycles. And then when you go to production, it'll be able to make tight, efficient, optimized code for the platform that it gets deployed on. Okay, so a quick tour of Dart, just so you know what it looks like. Okay, so here's an example of type safety. JavaScript, you know, we're assigning a variable. In Dart, we can do the same thing. We can declare the type, or we can let it be inferred. It saves us a lot of typing, but we still get the benefit of the static type checking and the runtime checks. Booleans in JavaScript, as we know, null or zero can evaluate to false. In Dart, only true is treated as true. Functions in Dart are pretty much exactly the same in shape. So you'll feel right at home there as well. Futures, just like promises, if you know the promises API, you'll be able to use futures and all of the different facets that they include. Async await keywords, these are pretty much the same as well. You'll be able to read any of this Dart code and be able to feel almost like you're reading JavaScript. Okay, so a demo. All right, so I have here what it looks like when you create a new Flutter application. So tooling-wise, you can use IntelliJ, which is what I'm using here, the Community or the Ultimate Edition. You can use Android Studio, you can use Visual Studio Code. There are several other tools as well. So here you go, you kind of come in here, we could create a project, we could select Flutter, and we could create this project. Your native code can be in Kotlin and Swift if you like. I've already created the project, and this is what it looks like. Okay, so I'm gonna boot these two up in the emulators. Flutter run. And while it's booting up, let's talk about the structure of this application. So in a Dart application, we've got a main entry point method, calls run app, and you give it a widget. Now, In Flutter, we call it a widget. In React, we call it a component, okay? There are two types of widgets, stateless and stateful, just like in React, okay? This top level root node is a stateless widget because it doesn't need to maintain any state. And everything in Flutter is a widget. The root application is a widget. The thing that provides theming data to your whole application is a widget. The thing that organizes your widgets into stacks are widget. Your widgets are widgets, and their children's are widgets. Everything's a widget. Zoom in? Sure thing. How's that? Well, that's maybe a little too close. Okay. All right, so here we have this material app, and we've got this application running in the right side. All this app does is just has a button and it counts up. This is the standard application that you get when you create a new Flutter project. Like I said, you've got a dev cycle. This is running in dev mode, so this is a just-in-time compiled. We get hot reload. So I can come in here and look at this theme data widget, and let's change this theme from blue to red. Come in here, reload our project. In less than a second, we've got our theme updated, which is great. Let's stick with the red. Let's call this Flutter for React Devs. You can change the title. You notice how Flutter automatically updates between iOS and Android. The iOS application has a centered title. The Android ones has on the left. There's lots of other subtle differences. The widget library I'm using right now is Material. Flutter provides a first-class implementation of Material. They're a reference implementation. If you like material design, there's really no better way to get material design than Flutter because of the tight workings of those teams together. So let's look at a stateful widget. Stateful widget really has two parts. You've got the declaration of the stateful widget up top here, and all this guy needs to be able to do is to take props and to be able to call create state, has a way to create the state object. The state object is the thing that holds the state. In this case, it's just an integer, a counter, has a function for to increment. We call set state just like we would in React, and we increment the counter up, and that triggers a frame redraw, and our build method gets called. The build method includes a scaffold, which is the kind of the frame you're looking at here. You've got the app bar at the top, you've got the body content, and you've also got this floating action button. The body content's wrapped in a center widget, which makes everything, all of its children into the center of its screen. And it's also wrapped in a column widget, which allows any of its child widgets to be stacked on top of one another. You'll notice that in Flutter, we don't have any style sheets, any CSS type styles. Everything is built into the object definitions themselves. We have objects, widgets, they have children or a child, and then they lay out their children, and they have children themselves too. And then we have this affordance for a floating action button. So we're going to add a little bit of functionality to the application. We're going to allow us to increment the counter like it currently does, and then we're going to allow us to decrement the counter as well. So we need to add functionality first. Let's come up here to where our increment counter was declared. And let's decrement counter. Make a call to set state. Let's make this counter go down 1. And there's our function. Down here under floating action button, we want more than one action button. So I'm going to want them stacked. So I'm going to be added on top and the subtract on bottom. So I'm going to wrap those guys in a column and copy and paste this guy. Have him call decrement counter and see what we get. We'll reload our application. Okay, cool. So we got our two buttons, but they're laid out in a weird spot. So this is because we've got a column, and the column likes to expand its height, and we just need to make sure that it's laying its children out towards the bottom. So I can go into the columns properties, and he's got a property called main axis alignment, and I can tell him to go to the end. I'll reload him, and now I've got my, my buttons where I want them. Now, those two buttons are a little squishy. I want them to have a little bit more space, and so there's a Flutter provided widget called a padding. I can add a padding around these two guys. Come and refresh. Now those are looking like I want. I come in here and make sure I test functionality out, and here we go. So I was able to Flutter has this stateful hot reload. I didn't have to reload the application, rebuild it, relaunch it, which might not be a big deal for you guys, but it is for me coming from a native dev world where a large application takes 8 minutes to build, and this comes in sub-second, which is pretty great. Okay, so let's add one more piece of functionality here. So I want to spruce up my application, and this scaffold, in addition to the app bar and the body, it's got something called a drawer, and they provide a drawer widget. So I'll add this drawer widget here. I'll come and refresh. You'll notice that I got this nice hamburger menu that pops over in my scaffold, and I can get this guy to come over, and I've got really nice material design drawer that comes over. So let's design my drawer. So inside of here, I've got a few things. The drawer takes a child, and Flutter also provides a user accounts drawer header. They've got some pretty sweet built-in widgets here. So I'll come and put my name in my account header. Okay. Save and reload that, see what happens. Okay, cool. So I got my account header. It's taken up a ton of space, and I want that guy to squeeze down, so I'm going to put him in a column. See what that does? Okay, there's our column. Our account header has a current account picture. I'll have a circular avatar guy, and we'll have the background image is a network image. I'll go grab my right here. Okay, it's my avatar. All right, here we go, reload that guy. There we go. We've got a cool application, and the Android one doesn't want to quite reload, so try that again. Well, I think he doesn't have any Wi-Fi, that's why. Okay, so we've got our application here. You see not a lot of code. Being able to do the hot reload is a big deal. Really productive environment, very familiar React type of framework, and having a lot of fun, a ton of fun with Flutter to be able to create high performance, quality, beautiful applications in record time. So a couple of last things to talk about with regard to Flutter. So to summarize, Flutter core advantages. So the core advantage I see in Flutter is that you've got complete control over all of your UI rendering. Okay, this is a big deal. Android and iOS UI toolkits were built over a decade ago, okay, without any sort of inspiration or motivation for a reactive framework. And this is a big problem. This is very difficult coding to be able to fit reactive frameworks into these old imperative UI toolkits. Because Flutter can take over all of the UI rendering itself and have a very true reactive framework, you can do all sorts of optimizations. You can have a no compromise API design. You can make decisions on how these widgets will work, not based on the lowest common denominator between the similarities on the platforms, but because of what it means in the design language you want to deliver to your users. Because of this also, you can run your UI in headless mode. So Flutter can render widgets in in unit tests rather than having to boot them onto device, which increases the amount of code that you can put under your unit tests, which is a big deal, I think. And because because this is driven by Google, however you feel about it, you get this holistic tooling environment. Dart builds the language, the build system, the debug server, the package manager. And they work closely with the Flutter team, who gives us the Flutter framework and the IDE plugins. And then they work closely with the material design team to make sure that the reference implementations in Flutter are true to form to what the design language that they're putting out. So you get quick dev iterations, speed, simplicity, and great runtime performance. So where is Flutter going? Oh, well, first, before that, Flutter disadvantages. Well, the other side of the coin to having control over the UI is that you have the responsibility over that UI as well. So you're beholden to the Flutter team to make sure that they're delivering the widgets that you need to use to communicate with your users. If they make a mistake, they omit things, there's not just a provided widget that your framework is going to be using by itself. And because of that, the three of us prove this is a far less ubiquitous tech stack as well, okay? There's not as many Dart developers currently. People aren't used to these tools. But I hope I've been able to demonstrate that because of your React and JavaScript backgrounds, these are accessible tools for you as well. So the last thing is, where is Flutter going? Currently, we've got Android and iOS deployments. This is out of beta. It's in production. It's in full support mode. They announced in December a project called Project Hummingbird, which will be able to take your Flutter application and deploy it without code changes to standards-based web. So the mobile app that we built here, be able to build a web application with Project Hummingbird. Today at the Mobile World Congress, they announced that they'll have a developer preview of Project Hummingbird within the next couple of months. They're also working on desktop deployments with desktop embedding with Mac OS, Windows, and Linux. So kind of imagine what that would look like, right? You got this pretty sweet counter application on a giant computer, but you don't have to imagine it because this application actually works. And actually, this is it's the same code, the same Dart code that we were just writing. And actually, this whole presentation is a Flutter application written and running on my Mac. It was built, so all of it's built from code that I built from source as a presentation application here for you. So this is kind of see the power, the versatility of what you can get with Flutter. So this is why it's interesting. Also, you have the skills to be able to get into this if you like. And I think there's a lot of opportunities coming up ahead. And that's it. Yeah. What's that? So the question is there feature parity? There's some things that work in Android and not in iOS. As far as the UI go, no. Because they handle their own UI drawing, the only thing that Flutter needs to be able to draw anywhere is just a surface, a context surface, canvas to be able to push pixels. But there are things, systems provided services that one platform will provide that another one won't, that don't have anything to do with the UI. So there's differences in how the location provider works, how Android services work. Like you can do arbitrary work in the background on Android in some contexts where you can't do that on iOS. And so there's certain system level integrations that you will have to do per platform. But from a UI perspective, there's really not any compromises between the platforms. Good question. Anybody else? Yeah.
Are you seeing much discussion between Flutter devs and React Native devs about like tooling or like certain things that they're both kind of using?
That's a good question. So the question is anything that discussion between the two platforms and maybe coming together on some of the toolings and things like that. You know, there's the official documentation I would point you to. They've got a lot of really great resources on flutter.io. And one of those pages is Flutter for React Native devs. So if you're coming from a React Native world, they kind of walk you through, these are the things that you are familiar with, and here's the map to what this means then on Flutter, and kind of guide you through there. The history of Dart is that in 2011, Google had this idea that they would build a language that'd be an alternative to JavaScript. And they wanted to build a virtual machine and convince web browsers to be able to bundle that in so that we could run a language other than JavaScript in the web. And they couldn't even get the Chrome team to do that. So that didn't work. And so they started to convince they pivoted into wanting to build an ahead of time compiled language so they can write Dart code and then compile the JavaScript and run it on the web. And so that's primarily the reason why Dart has its two compilation mode channels, because they have this VM mode for development and this ahead of time compile mode, like when they were generating JavaScript, which they still do today. You can write Dart for the web. They've got Angular Dart. Workiva's got an over React library that's Dart bindings for React directly. And so there are some crossovers and collaboration between the platforms as well.
Like, do you do a brew install Dart?
Yeah, so on Flutter.io, you'll download it. You can check it out. It's just a Git repo. You check it out and you run it. And you put the tools on the path. It compiles and runs. It's super easy to get started. I don't think there's a brew install. I think you can download the repo zip directly, or you can just check it out from source.
It's not like
Say again?
Workout has its own like development framework. You download everything separate install.
Yeah, so I mean they've got. I'll show you. Let's just kind of go over to here, Flutter.io. Get started. And we have our installations here, and we can download the stable zip. We unzip it, we add it to our path, and we run Flutter Doctor. It builds it and installs everything that we need to. On per platforms, you got to make sure you got Xcode. You got to make sure you have the Android Studio if you want to develop for iOS or for Android. You got to get tools. There's the plugins for IntelliJ, Android Studio, Visual Studio Code, and this kind of walks you through the process of getting it all set up. Pretty straightforward. Not a lot of gotchas, I should say. Question, yeah. Say again. Compared to PWAs? I'm sorry, I can't. Progressive web apps. How does it compare to progressive web apps? So different technologies. What's interesting about the PWAs is when they announced the Project Hummingbird in December, the deployment of our Flutter apps to web, they actually also, side note, told us that the Flutter deployed web app will work as a PWA also. So you can just hit the web application that's built with Flutter and load it on your desktop and be able to run it at a native layer. So that's an interesting concept. But you can use Dart code if you're using running like Angular Dart to build PWAs as well. But the Flutter toolkit itself doesn't have any PWA specific capabilities besides what they may do with Project Hummingbird. Anybody else? Cool. Well, thanks, guys. Oh, wait, one more? Oh, the garbage collection. So they've got, there's a pretty good article about the garbage collection. They've got, it's a, what do they call it? It's a progressive garbage collector. This is a technical detail. It kind of went over my head a little bit, but so they work with the Flutter framework, the Dart language and the runtime works with the Flutter framework to be able to know when those vseek events happen, to be able to hit those 16 millisecond sweet spot at 60 frames per second, and so that they can be able to kind of look at all that young space of all the new objects that get generated by the framework and be able to kick those things out. There's a pretty good article. I'll send that to the meetup group that gives more details about garbage collection. All right, that's it now. Thank you.